So our next talk is from Zack Chen. He's from Omnieyes, Taiwan. So Zack, it is great to have you speak at the event. I'll give you a brief introduction. So Zack Chen is currently a business development manager in Omnieyes. It's an AI-based startup in Taiwan. So he specializes in developing new markets by planning and implementing go-to-market strategies. So prior to joining Omnieyes, he has delivered several products and accounted for a large increase in sales revenue of his department at Macelot Industrial. He has successfully implemented My Fleet TM, the first commercial product of Omnieyes, to one of the biggest logistic fleet in Taiwan in July 2020. So Zach, it's great to have you speak at the event. I invite you to go ahead and give your talk.
Thank you.
Zach, you can share your screen.
Oh, okay. Wait a second. Do you see my slides?
Yes, Zach. Yes, please go ahead. Yeah.
Okay. Wait a second. Okay, so thank you for your introducing. Good afternoon, everyone. This is Zack from Omnieyes. It's really nice to have this opportunity to share with you about our experience on video analytics by using edge computing. Today, I will give you a very quick overview about my company, including our company profile, purpose, solutions, and of course, our technologies. Okay. My company Omnieyes is an AI startup located in Taiwan. Our three co-founders are professors in National Taiwan University, which is one of the best university in Taiwan and in Asia. And they all respectively specialize in wireless networking, machine learning, and data mining. And about our team, currently we have 18 people, and most of them are engineers. Besides that, we have a 10-person joint research team in National Taiwan University, including 2 PhD and a master. They're helping Omnieyes to develop our cutting-edge technologies. And about our customer engagement, we have commercial customers like Pelican Express, which is one of the biggest logistic fleets in Taiwan. And also we have a lot of potential customers who are running POC project with Omnieyes in many different countries, for example, in Japan, in Vietnam, in United States, and of course in Taiwan. And since we're a software company, we have a lot of hardware manufacturers and system integration partners. So that we can ensure our solution can be easy to implement to every kind of customer's scenarios. And about our company purpose, we collect street videos from mobile cameras, such as the dash camera in your car, in the taxi, or the cameras on the mobile phones. And we monetize these real-time street videos by using our connected edge AI to provide various 2B and 2C services. And our first product, My Fleet, which is a video-based AI fleet management solution, has been launched in July this year, which can help business fleet managers to fully understand the driving behaviors of their drivers. And about our product, I will give you more details later in my talk today. So why we choose edge computing but not cloud computing? I believe you guys are very, very familiar with the pros and cons of edge computing and cloud computing. Thanks for this winter school. And as we know, there are some well-known weaknesses on cloud computing, such as the computing cost is too high, the constraint on network bandwidth and coverage, and the delays incurred by cloud computing. And all of these problems can be solved if we adopt edge computing technologies. However, if we do this, here comes another problem, which is you may need to buy a very powerful device to conduct all of your AI models on that device, which means that device might cost you a lot. So what our engineers doing is not to improve the accuracy of our AI models as possible as they can, but what they really doing is to make our AI models as light as they can do. In other words, what Omnieyes is doing is to develop the technology of lightweight edge computing. By doing so, we can make our AI affordable, reliable, and easy to scale up. And now let's talk about how we monetize the live stream videos by using our lightweight edge AI. So before we started, I would like to share a video with you to give you a brief idea of what Omnieyes is doing. It is only 30 seconds. Please just watch the video and tell me what did you see in these videos. Okay, so what did you see in these videos? I believe most of you has recognized this driver has done some unsafe driving behaviors like red light running and wrong way drivings, of course. And some of you might recognize that most of the store on that street are closed. And if you are seeing more carefully, you might find out there are some raindrops on the windshield, which means maybe it is a rainy day. So even we are seeing the same video, the result we got still might be different because each of us has different preference. Some people who saw the red light running might because they care about the driver behaviors, and some people who saw the raindrops might because they want to know the weather. And it is the same for our customers. Different customer has different preference. For example, the taxi fleet manager may care about the illegal parking on the red curbs, but for in the same scenario, for logistic fleet managers, they may think the parking violation is not a big deal. What they really care about is like red light running or no stop at stop sign, because that is the biggest reasons for car accident happens. So by using our software-defined sensing technologies, we can collect the data from the videos exactly based on our customers' needs. And this is what we are doing and where our values lies in. So what kind of data we can extract from these street videos, and what kind of solutions that Omnieyes can provide by using this data? Currently, we can collect many kinds of data from the videos, and we can separate them into 6 groups. The first one is property, which include the vehicle, the data like vehicle, including license plate, the building, the bus stop station, and the point of POI, which is point of interest, including the signboard. And the next one is street view, which including the geometry of the road and new road detection. And then the traffic sign and markers, which include the traffic light, traffic sign, road marking, temporary tread sign, and temporary roads. And then the cars and people, which includes traffic flows and pedestrian flow. And the last one is weather. By combining all these data with Omnieyes technologies, we can develop various applications for many different domain areas, including smart city, search navigation, driving behaviors, and ADAS autonomous drivings. And in the following slides, I will going to show you how Omnieyes can help in each of domain areas. So the first domain area is smart city. Omnieyes we can provide the solutions like loss enforcement and asset positioning. About loss enforcement, I would like to share with you a real case that we worked with Taipei municipal government last year. They equipped 100 buses with Omnieyes solutions to detect the illegal parking in the bus stop areas. So why they want to run this POC? That is because the illegal parking in some bus station are so severe that the buses cannot pick up and drop off their passenger nearby the roadside, which will put their passenger in danger and cause the traffic jam during the peak hours. So They are looking for a solution which can help them to detect and report illegal parking vehicle automatically and prevent the people from parking in the bus stop area in the futures. And now let's see how we do this. Okay, in these videos, firstly, you can see we detect the bus grid, the bus station, and so that we can understand it is a bus station. And in the same time, you will see we also detect the car and we assign every car a number for tracking. For example, you can see there is the number 6 and number 7 car in the video in this snapshot. And by tracking this car, we can understand the car is moving or not. If they are not moving, we will take it as we will take it as an illegal parking car, and we will send the videos back to our cloud automatically. I just continue the videos. You can see the bus is stopped here, and the cars nearby they're just passing, but the front, the orange one is still just stopped here. So we take it as an illegal parking vehicle. But you may ask, how do we verify if this car is not maybe waiting for a red light, for example? It is for this case, we can easily verify this by checking the videos on cases. So when your customer send out the doubt on this case, we can just let him see these videos. So after the bus passed by this orange car, we can see maybe he really did the illegal parking. So we can verify this is it is really illegal parking violations. And about our asset positioning, as you can see in these videos, we can detect the vehicle, including license plate, bus stations, and actually it is all software defined. So we can tailor our detecting object based on our customers' needs. By combining with GPS and our semi-HD positioning technologies, which I will elaborate more in the following slides, we can locate the objects with higher precision, and that's why we can provide the solutions like asset positioning for government, for bank, or other customers who want to locate their assets on the road or beside the street. Okay. And the next one, the second domain area is search navigation. Omnieyes we can provide the solutions like POI update and visual guidance. About POI updates, I would like to ask you a question first. I believe most of you have the experience of using Google Street View, right? But did you know what is the update frequency of the Google Street View? Actually, we have done a research for this question. And finally, we find out averagely it takes about 12 to 18 months to update the map for one time in the downtown area of Taipei. So how did you think? Is that quick enough? To be honest, I'm afraid my answer is no, because when I want to see the street view in most cases, I don't think the street view over 1 year ago might be very helpful. But why it takes so long for map providers to update their map? One of the biggest reasons is because the road survey vehicle is too expensive to scale up, so that map providers cannot update the street view more quickly, since it will cost them too much for buying more road survey vehicles. However, Omnieyes can help on this case. You can see the image here. The left one is the snapshot from the Google Street View, and the right one is the snapshot from the device we mounted on our customer's truck. Our technology can compare the street view in real time by using our HAI, and if it finds out there is any difference, for example, the store has been changed or the new road has been detected, our AI will update the map automatically. So every vehicle carry Omnieyes solutions can become a lightweight road survey vehicle. In this way, we can help the map providers to update their map with higher efficiency and with lower cost. And another solution for search navigation is visual guidance, which is an unique AI plus AR solution for our navigation partners. So I just show you the video. In this video, you can see we detect a lot of signboards, but can you figure out what's the common for these signboards? Okay, the answer is these signboards are all located at the intersections. Now you can see here's the signboard Goodyear at the intersections, and the signboard here's Louisa Cafe in the intersections. But why we detect the signboard at intersections? Please just record your experience on using the current navigation service. When you're driving, have you ever accidentally take the wrong turns before or after the intersection that you should take turns? I believe most of drivers have this kind of experience. That is because the instruction of, for example, after 50 meters, you should turn right. It might be very ambiguous to many people. And needless to say, if there are many intersections are very close, it will become very, very confusing for the drivers. Although there are some solutions try to fix this problem by using POI and audio instruction, but it is still very hard for drivers to use. For example, the navigation told you to turn right at the intersection of the Louisa Cafe, but there's no time for drivers to figure out where's the Louisa Cafe when he's driving. So that's the reason this help is very limited. So what we do is using the audio plus visual instruction. We frame the POI here, like the screen, and we tell them to turn on the at the intersection of the Louisa Cafe. And by using in this way, we believe it is the most instinctive way to give the drivers a clear instruction when they are driving, so they don't have to do anything, and they can figure out, oh, I should turn left at that intersections. And it will be, we believe it will be very helpful for them. And the next domain area is driver behaviors, which is currently the most mature part in Omnieyes product portfolios. We have solutions for usage-based insurance and fleet management system. Both of them are extremely correlated with driver behaviors. So you may ask how we detect the driver behaviors. Actually, we're not doing the same thing as most of DMS supplier. DMS means driver management system. We are not doing like them. They're using a camera facing the drivers to detect the fatigue, distraction, or other unsafe behavior of the drivers. But what Omnieyes is doing is totally different. We tilt the camera 180 degrees to face forward. So you can see our videos like this. We're facing out, not facing in. And you can see here's some feature point, the green dots, we call it feature points. Okay. So you can see there are many green dots on the screen, which is the feature point. And the tails of these feature points means the direction of the vehicle. So we can detect the traffic sign and markers, and also we can detect the motion of the vehicle. By combining all this information we collected, we can finally understand the real driving behaviors of these drivers. And currently, we can detect many unsafe driving behaviors, including the traffic violation like red light running, no stop at stop sign, and wrong-way driving, and illegal parking like parking on the crosswalk, parking on the red curb, or parking in the bus stop area. And all these unsafe driving behaviors will lead to traffic tickets, insurance, property damage, and not to mention the corporate image, which will affect our customers' business directly or indirectly. And that's why they are willing to use our solutions to coach or manage their drivers. Sorry, I don't know why it skips a lot of slides. Okay, click on these slides. And for the last part, which is ADAS and autonomous drivings in this domain area, actually we're not planning to provide a solution of ADAS or autonomous driving. However, what we're planning to do is to provide a high precision dynamic data, for example, for existing applications. As you know, one of the essential elements for autonomous driving is high precision map, which including two parts. The first part is the static map, which means the geometry of the road. And the second part is the dynamic information, which including all kinds of real-time street information like traffic flows, pedestrian flow, temporary walking zone, weather, and etc. Although many map providers are trying to build up their own high precision map, but since the roads of a vehicle are too expensive to scale up, it is very hard for them to increase the update frequency of the map. And eventually, they can only choose to update the static map, but cannot collect the dynamic street informations. And that is the part Omnieyes can offers. Besides the technology of segmentation, which many suppliers can do, what really makes Omnieyes special is we can use a single monocular camera to detect the distance between the vehicle and the object we detected. And we can control the arrow within 2 to 3 meters. So you can see the videos here. The darker parts, the more darker means the distance is more longer. So you will see, okay, if you can see here, there is a motorcycle here. So you can see there is a motorcycle here. So you can see there is a brighter part here. It means the distance between me and this object is smaller. And also our land recognition technology can help us to understand exactly which land we are located in. You can see the videos like this. Here's show the location 1. The numbers means from the left. So we are located in the first land. Here we are located in the second land from the left. And when we going through an intersection, because there's no land here, so the location will be shown as 0. So by using this technology, we not only we can understand exactly which land we are located in, we can also understand the land-based traffic flows in the same time. Eventually, we can collect many kinds of high precision dynamic data for high precision map and autonomous driving application using. Okay, just quick summary. So in summary, Omnieyes had 3 core technology, which is lightweight edge AI, software-defined sensing, semi-HD positioning. By combining the technology of lightweight edge AI, the software-defined sensing, and we developed an affordable fleet management system, my fleet, which has been officially launched in July this year. And until today, there are over 1,000 of vehicles are carrying this solution right now. And combining the technology of lightweight edge AI and semi-HD positioning, we can deliver the solutions like navigation and some real-time alerts functions like ADAS. And combining the technology of software-defined sensing and semi-HD positioning, we can also provide the high-precision dynamic information, including structured data and videos for maps. And eventually, these three technologies will help us to monetize the videos and make our AI affordable, reliable, and easy to scale up. And this is my end of my talk today. Thank you.
Thank you, Zack. That was a pretty interesting talk.
Thank you.
So good to have you speak at the event. Let me see if there are any questions in the question answer box.
Okay.
So Zack, I have a question. I'll just put forward my question. So so I was just wondering, like, what do you mean by monetization here in the whole topic that you dealt with? What is the meaning of monetization?
Monetization is it means to make money by using these data, because in the past we have a dash camera. It record many hours videos, tons of hours videos. For example, for a business driver, for a logistic fleet drivers, maybe his running hour is 10 hours per day, but actually maybe just 5 minutes videos is valuable because they really have an accident for and he need these 5 minutes videos to see if who is have to responsible for these accidents. So in the past, about 9 hours and 55 minutes videos, they're useless for the drivers, but actually it captures a lot of information and the data which I just mentioned in my slides and in this talk. And this data is very valuable, but they cannot, the drivers, he cannot to extract these data from the raw video footage. But what we do is collect the data from these videos and to make it structure and make it usable for some to find some people who need these data. So what we talk about monetize there is mean this.
Zack, there's a last question. So I see one more question. Other than cameras, do you see a merit in using LiDARs for some of the use cases?
I think everything. I just use a simple word to elaborate for this case. Actually, we can detect everything in the videos. You can see if anything you can see in that videos, we can detect. But there's becomes another question, which is precision. What we can do is the precision of the detected. We cannot be, for example, the distance. We cannot do it as precise as radar do, but we still can do that, but just is still some limitation here.
Okay, Zack, thanks a lot. So that was a very interesting talk, and thanks for joining us and giving this talk.